Hello, this is Mrs. Decker, and this is Objective 1C on solving average atomic mass problems using isotopes and mass abundance. So in a previous lesson, we talked a little bit about the atomic masses that are on the periodic tables and why they're decimals. And that's because we take the percent abundance of all of the different isotopes there are in nature and use those to calculate the average atomic mass, which is what is put on the periodic table. So today we're going to learn how to calculate those average atomic masses. So we can use experimental procedures to find out the percent abundances of the different isotopes of the elements that are in nature. So here's some information for the two different isotopes of chlorine. We have chlorine 35, which its mass is 34.969, and its percent abundance in the atmosphere is 75.53%. We also have chlorine 37, and its mass is 36.966, and its percent abundance is 24.47%. So I want to talk for just a second about this AMU. AMU stands for atomic mass unit, which is roughly the mass of one proton or one neutron. So it's a made-up unit by scientists to represent the mass of a proton or a neutron. Okay, so to calculate the average atomic mass, you take the first mass and multiply it by the first abundance and add it to the second mass multiplied by the second abundance. So now it's important to note that when you're putting in the abundances, we don't want them in percents, we want them in decimals. Otherwise, you will not get the correct answer. So to calculate the average atomic mass, we would do 34.969 times 0.7553. So to go from the percent abundance to change it into a decimal, you're just going to divide by 100 or move the decimal 2 places. And then we're going to add that to 36.966 times 0.2447. Okay, so when we calculate that, we get an average atomic mass of 35.46 AMU. So it's important to make sure that when you write your answer, that you are including the units. So for average atomic mass, we're going to use AMU. All right, here's another example for us to work on. It says neon has two major isotopes, neon 20 and neon 22. Out of every 250 neon atoms, 225 will be neon 20, and here's the mass of a neon 20 atom, and 25 will be neon 22. And here's the mass of a neon 22 atom. We need to calculate the average atomic mass of neon. So we have one of the pieces of information we need, which is the mass of each of the different isotopes. We're missing the second piece of information we need, which is the percent abundance. However, with the other information that is given, we can calculate the percent abundance. So for neon 20, it says that 225 atoms out of every 250 will be neon 20. So when you divide that, you get 0.9, which is your percent abundance for neon 20. And then for neon 22, 25 atoms out of every 250 will be neon 22, which gives us an abundance of 0.1. So now we have our masses and our abundances, so we can plug them in. So we will do 19.992 times 0.9 plus 21.991 times 0.1. So when you plug that into your calculator, you get an average atomic mass of 20.19 AMU. Again, remember to make sure you include your units. So now you have some practice problems to work on in your packet. Let me know if you have any questions.